Hello students, at the junction of this chapter we have learned that so many formulas, so many relationship differences and similarities between solenoid, toroid and whatnot. Right now we are at the junction of this point where we will discuss about or capable enough to discuss or bring it out differences and similarities between electric and magnetic field. So first of all we will just discuss about so many similarities, and then we will discuss about its differences. So students, we have learned that so many similarities. So first of all I am just comparing this part. Let's say both our electric and magnetic forces are or fields of long range, because they are existing at a very long distances. As you can just say that E is having relationship which is called as inversely proportional. So E is inversely proportional to 1 upon r square, and r is larger, E is smaller. Same is the course for the B, which is proportional to r square. Though you are aware that whenever you have a electric dipole moment, you have over here that is called as a P, which is called as a electric dipole moment, while in the B we have a magnetic dipole moment. Generally we are just calling it as a M. So whenever such type of relationships are there, and this relationship is supposed to be changed, it is not 1 upon r square, it is called as a 1 upon r cube. So this is very primitive differences first of all we have. Next one is called as a this both E, both our electric field and magnetic field follows or possess superposition theorem. So you can just say that there would be a sum of so many electric fields that is starting from E1 E2 up to so on, and that is called as up to n. And so is the course for magnetic field, it is starting from B1 B2 up to so on, and that is called as a Bn. So such type of a primary differences similarities we have. Next one is that our electric field is only because of that electric charge q, while magnetic field is only available from our current carrying conductor or current segment. So you I am just using this word, that is only because of current segment. So you can just say that these are the rules, these are the similarities of our electric field and magnetic field lines. Now we are discussing about dissimilarities or differences. Very first difference is that our electric charge, which is called as a scalar quantity, while my magnetic, or you can say current segment, which is I have mentioned in throughout my all lectures, that is called as a vector quantity. Next is called as our electric part, which is following dot product, and when my magnetic is following that cross product. Last not least is also important one, electric field is independent of angle theta, while my magnetic field is dependent on angle theta. So in electric field we are not bothering about dot or cross notation, because we are habitual that electric field lines are passing from plus to minus, which is vice versa for the dipole. But in magnetic field we have to be very cautious about our thumb rule, where our magnetic field lines are entering, where it is going outside. So I have just pointed it out similarities and differences for you. So be careful in this chapter. Either in a school or board exams they are asking for the 2 or 3 marks 2 marks theory basically. either the similarity and differences of a solenoid and toroid, or they may ask you that what are the similarities and of electric field and magnetic field. Yes, you can also point it out that there is one more similarity, that you have integration that E dot dl is called as sigma q by epsilon 0. In same course you have here ampere circuital rule, instead of dl you have dA, b dot dl, that is called as a mu 0, and these are the similarities. But also you can also point it out so many differences as well. So keep in mind these formulas, keep in mind this relationship, because as usually I am using such type of words in regular lectures, that whenever you have thoroughly studied chapter number 1 and 2 static electricity, you will be capable enough to find it out similarities, differences and relationship of magnetic field as well, because both the chapters have some of the differences of a concept, some of the constants. Otherwise both chapter deals with the such type of some of the primitive common factor or characteristics. So keep in mind and focus on such type of similarities and differences in, and accumulate both those similarities and differences in your mind. Thank you.